Question number 14 gives us a table of values, and we want to find out how many solutions this has. So plotting out the points, I've plotted the red table with the red dots and the green table with the green dots, and we can see that if I just kind of sketch this diagram in, now I kind of want to have a symmetrical point here. I can see that I have vertices, so I have a vertex at 0. So I'm going to maybe make my point here, and I can sketch my green graph, something like that. Okay, and then using the red coordinates, again, I'm going to sketch a symmetrical point here because I can see that there's symmetry at x equals -3, and I'm going to sketch the parabola here. Okay, so we can kind of see, it's hard to see, but the red parabola looks like it is a little bit more compressed than the green parabola. I'm just going to redraw this. So the green parabola looks like it has a vertical expansion involved, so it looks thinner, and my red parabola looks a little bit wider based on the coordinates here. So what should happen eventually is that we're going to have some sort of intersection over here. We have an intersection here. So we should have two solutions. And estimating the solution, okay, the estimate of this one here looks like it's somewhere at about negative, I'm just going to say about -1.5 and maybe 2.5. Okay, so there's one solution. And the other solution, again, if we kind of extend this, it's hard to see, but I'm just going to say maybe somewhere around x is 3 and maybe somewhere around 50. Okay, that estimate looks like it's going to be a bit far off, but we're just going to kind of estimate that based on the graph. So we want to determine a quadratic equation for these. So for the red graph, I'm going to start with the vertex. The vertex is going to be at x equals -3, so it's going to be x plus 3 squared plus 0. I'm going to solve for the a by just plugging in one of the coordinates. I'm just going to put the first coordinate in. So it's going to be -5 plus 3 squared. So that's going to be +4. So a equals 1. Okay, so there's my equation. Y equals x plus 3 squared. For the green graph, I'm going to come up with the equation using my vertex at 0, 0. So y equals ax squared. It looks like there's a vertical expansion, and when I plug in the first coordinate, y equals 2 when x equals -1, we have a vertical expansion of 2. So my second equation is going to be 2x squared. Okay, so then I'm going to make these equal to each other. 2x squared is equal to, and I can expand it out, x squared plus 6x plus 9. Make this equation equal to 0 and solve. So I'm going to end up with x squared minus 6x minus 9, and that's equal to 0. I'll plug this into the quadratic formula, so I get 6 plus minus the square root of 36 minus 4 times a times c. And that's all over 2. Just simplifying the quadratic here, I'm going to end up with 36 plus 36, or 72 over 2. Okay, we can plug this into our calculator to get a value. So plugging into the calculator, I end up with 6 plus 72 square root divided by 2, and that gives me about 7.24. Okay, and then I'm going to do 6 minus 72 square root divided by 2, and that gives me about negative 1.24. Okay, so those are my x solutions, and I can see that my x solution here is fairly close. This one was way off, and I'd have to sketch this graph a little bit better to get this to look better. Now you can kind of see that I've kind of bent it over, so it's kind of angling it the wrong direction anyways. So that that 7.24 solution is not necessarily very accurate. Okay, so I do need to solve for y. So plugging into the y for x is equal to, I'm just going to estimate this here, so x is equal to 7.24. We get a y value of about 17, so 7.24, 17.98. Okay, so that's one set of solutions. The other set of solutions is negative 1.24, and when I plug negative 1.24 into there, okay, I get a value of about 7.62. Okay, so those represent my two solutions. One of them wasn't too far off. The other one was quite a bit off.